In this video, we'll be looking at the proof of the product rule for derivatives. Now, this is the product rule right here, f of x times g of x. The derivative of these two functions multiplied together is equal to the derivative of the first times the second plus the derivative of the second times the first. That's the nice little pattern in which you can help remember this. Again, it's the derivative of the first function times the second function unchanged plus the derivative of the second function times the first function unchanged. Now, for us to prove this, we unfortunately have to go back to the limit definition of a derivative, because the rules that we currently have up to this point aren't viable to prove the product rule for generic functions. So for us to do this, we have to recall that the derivative of any given function f of x is the same thing as the limit as h goes to 0 of f of x plus h minus f of x all divided by h. Now, keep in mind this doesn't have to be used in terms of h. It's the same thing as delta x going to 0. I just prefer using h because I'm lazy and it's less writing. So if we were to use this same exact formula, I'd go f of x plus delta x minus f of x all divided by delta x. But I'm again going to stick to this format of h. It's also important to note that this can be done for g. So in case we need to see it, g prime of x, this function right here, is the same thing as the limit as h goes to 0 of g of x plus h minus g of x all divided by h. Again, this holds true if we want to replace it with delta x, but we'll stop there for the delta x. So again, we're going to use these two rules right here to help us evaluate the limit definition of the derivative of this product. So in that case, if I'm looking for f of x times g of x using the notation of either prime for the derivative or d dx for the derivative, so I'm going to differentiate this whole function in respect to x, I need to be able to evaluate the limit as h goes to 0 of the, now notice again, this right here is the limit definition of any generic function f, so if I have two functions multiplied together, it should still hold true, meaning that if this is the function that I have, I'm going to have that function with x plus h replacing the x minus the original function again with just x all divided by h. So this is the original function. I'm going to have f of x plus h times g of x plus h. That's again the original function replacing the x plus h minus, again, the original function is then f of x times g of x. And this whole thing is divided by h. So I need to identify what this limit actually is going to be. Without using some creative thinking is what I'm going to call it, we can't really evaluate this limit. And more importantly, we can't get this limit right here to equal to this function. If it also helps to give us the end goal, knowing that we know that this is the product rule, we know that this thing right here should be this, and this thing right here should be this. So in some way, we have to manipulate this limit in order to split it up into two separate functions with an addition sign between them, such that we have the limit definition of f of x and the limit definition of g of x in two separate spots. Well, again, this creative thinking is how this is going to be done, and keep in mind that this creative thinking pans with both the quotient rule as well as any other proof of a derivative function. There's something tricky that you have to introduce before things are going to work out nicely. Well, in this case, the thing I'm going to do is I'm going to go ahead and leave this f of x plus h and g of x plus h alone. I'm going to leave it dividing by h. I'm also going to go ahead and move this f of x times g of x all the way over here. I'm going to wait to write that down, though, so that I make sure I have enough room. I'm going to start by subtracting from this an f of x times a g of x plus h. Now, this might seem, again, coming out of nowhere. It's the creative thinking part. It's me saying, well, I know that up here, this f prime of x times g of x, I need me to have this thing right here in some way multiplied by g of x. I need this thing right here in some way multiplied by g of x, which if I look at these two terms right now and I pull out g of x plus h, yeah, I know it's not quite g of x, but if I pull out g of x plus h, I'm going to be left with the f of x plus h minus f of x. So this is still all divided by h, because otherwise it's not going to work out nicely. Now, also you're like, well, wait a second. I can't just subtract something arbitrarily from here. Well, I can, as long as I add the same thing. So I'm going to go ahead and add the same thing. Now, arguably, I didn't really change this limit at all because mathematically they're the same. These two things are the same, so they'll just cancel each other out. Also, mathematically, I need to leave this f of x times g of x in here, still all divided by h. Again, this right here is the creative thinking step. I've subtracted this thing, and then I've added this thing, noticing that, again, those two things can cancel each other out, and I'll be left with this minus this, which is, again, the original limit I started with. So the next step that I'm going to do is I'm going to go ahead and group this with this and this with this. So I subtracted this piece because I knew that I could factor out the g x plus h out of both of those terms. So that's what I'm going to go ahead and do. H approaches 0. I'm going to factor out g of x plus h out of both of these terms, leaving me with f of x plus h minus f of x. This still divided by h, this still divided by h, which I'm just going to go ahead and make that 1 division by h. You'll notice now that this right here is this piece of f prime, which is what I need, and I have g of x plus h, which, again, isn't g of x, but we'll get there. It's almost there. Over here, I'm just going to go ahead and see what things I can do. So I'm going to go ahead and have addition. Keep in mind that this is the limit of the whole thing, so technically I should have brackets around this whole thing. What I'm going to do is I'm going to distribute this limit over addition because that's allowed to be done. So it's the limit of this piece plus the limit of this piece. So I'm going to rewrite limit in here as h goes to 0 of, and I'm going to go ahead and factor out, in this case, notice the f of x is in common between those two terms. So I'm going to have f of x, and I shouldn't have used brackets here, but what's done is done. I'm factoring out the f of x, so I'm going to have g of x plus h. I'm going to have minus g of x, and I'm going to have this whole thing still divided by h. Again, notice, again, each of these pieces have h, so I can go ahead and combine that together. Now, keep in mind one last time that I used the limit definition of being able to distribute this limit over addition. It's also true that I can distribute the limit over multiplication, assuming both of those limits exist separately. So in that case, the limit of this whole thing, I'm technically evaluating limit as this thing as h goes to 0 of this function and h goes to 0 of this function. So when I do that, I'm going to have the limit as h goes to 0 of g of x plus h times the limit as h goes to 0 of this thing, f of x plus h, minus f of x, divided by h. I'm going to have that added to the limit of just f of x, so the limit as h goes to 0 of f of x, and then finally times the limit as h goes to 0 of this thing here, this g of x plus h, minus g of x, all divided by h. So now I can evaluate each of these four limits separately. The limit as h goes to 0 of this thing, well, this h just goes to 0, so it's just going to be g of x. So I have simply g of x times. Well, the limit as h goes to 0 of f of x plus h minus f of x, all divided by h, this whole thing, by the definition of the limit, is this f prime. Again, notice f of x plus h minus f of x, all divided by h, that's f prime of x. This right here is f prime of x, so multiplied by f prime of x. Plus, over here, I have the limit as f of x, limit of f of x as h goes to 0. That's just f of x, because the limit h doesn't do anything to this if there's no h in there. And then this right here is simply g prime of x. Now, you'll notice that the order in which of this is slightly off, simply because I didn't keep the order of the terms that I probably should have in the correct order. But you'll notice that I can rearrange multiplication and end up with the derivative of the first function, f of x, times the second function unchanged, plus the derivative of the second function times the first function unchanged. So again, this is how you take the derivative of a product without using the product rule, but instead proving that the product rule works using the limit definition of a derivative. The same holds true for the quotient rule. So again, you just have f divided by g. You set it up in this particular rule, and then there's a creative step of figuring out what you need to either add or subtract, what you need to multiply by. There's something you need to add to the problem that doesn't change the mathematical value of the problem. Again, notice this was just 0. But all in all, still allows you to evaluate, manipulate until you get down to the rule in and of itself.